but also can be very helpful if you just want to understand what's happening under the hood in a typical Gradle build. So let me start by asking how many of you maybe configure your build in your companies for your hobby projects. So so pretty much everyone. How many of you do any kind of custom stuff? So writing tasks, writing plugins? Quite a lot. Okay, so let's hope this talk is helpful for you. Okay, so what we're going to talk about today. First, before we actually get into any of the new stuff, I want to do a small Gradle refresher. So even if you know some of that stuff, maybe it will be helpful for anyone coming to this talk to understand the topics that we'll be covering later. So we'll talk a little bit about the Gradle basics, and then we'll move on to talk about the newish APIs that we have. Newish because we started adding them in 4.2. Some of them went stable in 7.0. Even more are becoming stable in 7.1. So they are in constant development. However, they are in a very much usable state right now. And this is the variant API and the artifact API that we're going to talk about later. Okay, so let's start to talk about Gradle basics. And it's not really basic in the sense that I didn't know most of that stuff before I actually researched it while working with the new APIs. And hopefully this part of the talk will be something useful for you. It's something that I wish I had known years ago when I started working with Gradle and configuring builds and trying to do stuff that maybe wasn't possible out of the box, but I didn't really know how Gradle works under the hood. So most of you probably know this if you've ever built something on the command line. The first thing you see is this kind of spinner that goes through various phases. You see initialization, configuration, execution. Well, actually, if you look really closely, initialization is something that you probably won't even see. It's just a very, very short phase. I'll talk about it in a sec about what happens, but it's not something. This is not a phase that we can influence. It just happens. It's very short. This is not a source of long build times for you. Now, the two next phases are more interesting. So configuration in this sample project is just a small sample, very little code, very little modules. Configuration can actually take quite a long time for a project like this, quite a big chunk of the total time of the total build time. And then execution. And execution is when all of the compilation happens, all of the basically heavy tasks that need to happen for you to build your app. And in a big project, this is the phase that grows longer and longer. The more source files you have, the more resources you have in your project, and so on. So we'll talk about basically what to do and what not to do to make these phases as optimal as possible. So what's initialization? So this is the phase where Gradle actually tries to figure out what's the project, what am I doing, like what kind of modules there are. And in the simplest case, it just looks for a build.gradle file in the folder where you run it. And that's, in the case of a single project build, that's the only project that you have. In a kind of multi-module or multi-project environment, that's also called the root project. So what is a multi-project build then? In fact, before checking for the build.gradle file, Gradle also looks for a settings.gradle file. And in that settings file, you can give Gradle a description of all the projects in your build. And so you can have other directories containing their own build.gradle files. And that's how Gradle is able to find them. And notice that I've already made this mistake once. I already said multi-module instead of multi-project. So that's because there's a slight confusion between how Gradle names things and how we name things in Android land. So Gradle, what we know is modules from Android Studio. Gradle calls them projects. So a typical Android build is a multi-project build in Gradle. It has the root project, it has maybe the main application module or project, and it has some library projects and so on. In Android land, in all of our documentation in Android Studio, we say you have one project that has modules. So we have the app module, the library modules, and so on. So if I make this mistake again, we can kind of use it interchangeably. But in Gradle, if you read Gradle's documentation, they will be called projects. Okay, so this is just initialization. Basically, Gradle reads the list of projects, finds the files, and creates a project instance for each of them that it will be using in the configuration phase later. And in the configuration phase, what it does is actually Gradle executes, evaluates all of those build scripts that it found. It applies the plugins that are in the build scripts, it registers tasks, and so on. So if you look at a typical build Gradle file, and I'm going to be showing KTS files, that's another way you can configure a project, either using Groovy or Kotlin script. The first thing you see normally at the top is the plugins that it's going to apply. So in this instance, I'm building an Android application. And by the way, when I say Android Gradle plugin, I'm cheating a little bit. It's actually a collection of plugins. So we have the com.android.application for building APK files or app bundles, but we also have com.android.library, we have test, we have a dynamic feature. So these are all plugins. But when I say AGP or Android Gradle plugin, I talk about the collection of plugins that we have. And then there are other plugins like plugins from JetBrains to compile Kotlin code, which if I have any Kotlin sources, I need to apply that as well. And we'll talk about it in a sec, about what these plugins actually do. And then usually after that, you have some configuration blocks, like the one we see here, Android, which is contributed by the Android plugin. This block is actually called an extension, and it uses this kind of DSL-like, so domain-specific language that lets you configure a build. It's very declarative. You're not supposed to write complicated code in there. It looks almost like a config file, and that's how it's supposed to look, but it translates to actual calls to actual Java classes or Kotlin classes under the hood. So what is a plugin then? How do we apply it to a project? What does it mean? Well, a plugin is actually a class that extends plugin from Gradle. And the one main entry point to this class is the apply method. So when we say, Gradle applies the plugins using the project instance that it created during the initialization phase, it just calls your apply function and gives you the project, which is kind of an entry point to the many things you can do with a Gradle project. So for example, you can register your own extensions. That's how Android actually contributes this Android block and lets you configure all the things that the plugin will use later on. Here in this example, we have some simple greetings plugin that creates some kind of extension block called greeting, where you can configure a message for it. Right, so if you actually want to see how that looks in the code, you can find the application extension class that Android creates in our reference documentation on our website. And then there you can find all of the configuration options, all of the configuration blocks that you can set on the Android extension. Because like I said, it's just a regular class that you call code on, even though it looks as in a kind of a declarative way. So another thing that plugins do is they register tasks. So here in this example, the greetings task registers a hello task. And if you call it, it will print some kind of message that you configured using the extension that you registered earlier in a in the build file. Now, the important thing to understand is all of this applying of the plugin happens during the configuration phase. The only thing that happens in the execution phase is the actual task action that we introduce here using this do last method. So basically, everything you do in the configuration phase should be fast. Whatever heavy lifting you need to do in your plugin, you need to delegate it, defer it to tasks as proper task actions. So actually, what I showed you here is a very simple way of registering a task by kind of declaring it in line. But what you can do is, and what you want to do if you want to keep your task maintainable and once your tasks start growing, you also declare them in separate files. And a task, again, just extends from a default task class from Gradle. And a task can have a number of things, and all of them are optional, by the way. So it can have inputs, it can have outputs, such as something that you configure on it that it will transform in some way, and then output maybe a file as part of your build, and then it can have actions. And again, the action is the thing that actually runs during the execution phase once you invoke your task. Now, setting inputs and outputs is very, very important to make your task cacheable. So whatever data has any influence over what the task does, what it produces as the output, should be properly marked as an input. And same with outputs. So Gradle can know about them and know when they change. Okay, but what happens if you actually want to do something like this? So we talked about the declarative way of configuring your builds. We talked about tasks, but what if you actually want to compute your version code from something, from maybe you have some kind of central repository for your company where you keep all the version codes. And during the build, you want to pull down some information from that repository and set the version code for your app accordingly. Well, if you do this, if you just try to do some computation in your configuration, then suddenly your configuration phase explodes, and every time you run your build, it will actually reach out to the server, download stuff, set it as a version code, and it's not something you want. Even if there's nothing to be done in your build, even if all tasks are already cached, all the inputs and outputs have been produced, and they exist on the disk, the next time you run it, the configuration phase will spin and spin and spin, and you'll have to wait for that network call to happen, which is not what we want. And so the main problem is we want to do as little work as possible during the configuration phase and defer everything to the execution phase. And we're going to talk about mechanisms that let you do that. Also, imagine after a successful configuration phase, all the plugins that you applied create all the tasks that they need. They create the connections between them, so some tasks depend on other tasks. And then you execute, let's say, task C on your command line. What happens is Gradle figures out which tasks need to run to satisfy that command. So it figures out all the dependencies. But then, if you think about it, why do we even need task A, B, and D if I'm not running them? Like, what about the time spent to configure them, to create them? Can we do anything better? Can we do something to not waste that time during configuration phase? And I'm going to show you how that can be done. So the main mechanism for deferring work to a later point in time in Gradle is the provider class. It is super important to everything that we'll be talking about today. And the provider is actually very simple. It just has a get method that lets you get a value from the provider. But the thing is about that class is that it's lazy. If you have a provider of something, of some value, that value will not be created. The Gradle would not attempt to basically execute any code to create that value unless and until someone calls get. So the very important part is to always call get on any provider in the execution phase, not in the configuration phase, to defer that work. And then there's another type, property, which subclasses provider, but it also lets you write values. So if provider is read-only, property also lets you set stuff. And on one hand, it can let you set a concrete specific value, which is kind of a fast action. You have the value already, you just set it on the property. Whenever someone queries the property, it will have that value. But the more interesting one is the second one. So it also lets you set a provider as a source of the value for the property. And again, it's lazy. So when you set a provider on a property, nothing happens. No, the provider is not executed. The get method is not executed. The whole chain becomes lazy. Only when someone asks for the value of the property will it ask the the source provider for the value and then compute it and hand it over to the whoever called get on the property. So how can we deal with a situation like this, for example, where we want to defer any heavy lifting for configuring tasks A, B, and D using these? So let's look at an example, download plugin, which downloads some file. We can register our download task. And register is the key here. So previously in Gradle, we used to use the create method, which did everything up front. Register is lazy. So when you register a task, you don't get a task instance, you get a task provider. So the task was not created. It was just registered so that Gradle can know its name, download. And you also pass in a configuration block, which is not executed at this moment. This configuration block will be executed only when that task is needed. And only when someone needs this task will this block be actually executed. And so then how do we connect it to something else? Let's say we want to print out the contents of the file that was downloaded by our download task. So we have another task called print task. And as its input, we're trying to set a file that will be printed out to the screen. But how can we do that? How can we get a file that's created and downloaded by the download task if the task doesn't exist yet? We only have a provider. So the two other very important methods that are supported on provider and property are these transformation methods called map and flat map. So in this case, you can transform a provider into some other type of provider in a lazy manner. So again, whenever you call map and flat map on a provider, you get another provider, but your transformation code did not execute yet. Only when someone calls get on the resulting provider will it kick off the whole sequence of events that will lead to actually creating that value that you need. So in this case, we can get our download task, which is actually a task provider, and we can flat map it to one of its outputs. So the download task has an output called downloaded file, and we can set it. So remember, the result of flat map is a provider. We set a provider as the input file, and now not only we have everything connected together in a lazy manner, no actual execution logic executed at this point. This is all configuration phase. But when someone actually runs the print file, it will notice that we need an input file for printing. And what's very important about the map and flat map methods is that they create an implicit dependency between tasks. So they carry dependency information. Once someone requires the input file to exist, it will notice that it's set to an output from the download task. And it will create and execute the download task to create that value for the print task. All clear so far? Cool. Yeah, so again, very important, mark all of your inputs and outputs. That's how Gradle actually knows that to create this connection between tasks and how, in order to satisfy the input, it needs the output of the other task. Okay, but we're talking about tasks a lot. The problem with tasks is that they are a brittle API. It's fine to do what I did. Everything's in my own plugin. I control the dependencies between tasks. If I change anything in the next version of my plugin, everything will work. I'm not depending on anyone else's tasks but my own. However, they should not be exposed as an API from a plugin. And let me show you why. So this is an actual situation, well, more or less, that happened in previous Android Gradle plugin versions. So imagine we have some compilation tasks in AGP that create classes. And then we have maybe a dexer that turns those classes into dex files. And someone thought, well, I want to write a plugin that transforms the classes. Maybe it's some kind of shrinker or something. They want to pre-process the classes before they're actually dexed. So they write their own task. They find the compilation task from our plugins, and they kind of redirect the output to their own task, and then they produce more classes and feed that into the dexer task. Well, all is fine until we release the next version of AGP. And maybe we decided to split the compilation into two steps, because maybe now we have a desugaring task that post-processes the classes to add Java 8 language features and so on. And suddenly, because we did that in a new version, but your plugin wasn't updated, suddenly what happens is you still try to rely on the compilation task because you don't know anything about the desugaring task. And so you take the wrong version of the classes. The desugaring task maybe doesn't run, or maybe it runs, but we discard its output. And suddenly, the whole build either breaks or is incorrect. And that's not something we want to happen. So I'll show you in a second how we can deal with this. And then AGP is not a simple plugin. It gets even more complicated than that. Let's say you want to figure out, so you still want to figure out what the tasks are, and you want to hook into the right places to transform stuff and register your own hooks. But the thing about Android Gradle plugin is that we have build types and we have product flavors, and AGP configures, takes all of them and builds all these variants of your app, creating hundreds of tasks for every combination, like if you have a free debug build of your app or a release paid version of your app. And then there are tests and everything. How do you figure all that out, and how do you make sure that it doesn't break on the next version? So that's why we're going to talk about the variant API that we introduced specifically for that. So we talked about the Gradle phases, and let's talk about Android Gradle plugin now. It actually, before it finishes its configuration, it has phases of its own that are super important to understand and know at which point you can do stuff in your own plugins. So first of all, we talked about this DSL configuration, this extension that you have in your build file. So the first thing that happens is AGP parses it. It sets all the values from your build files on the extension, and then it locks it because it will be using it to create other kinds of objects, and we don't want anyone touching them after they are used to configure your variants. So we take the DSL objects, we combine all the build types and the product flavors and everything, and we create variants. At this point, if anyone were to modify the DSL objects, that information will get lost. That's why the locking happens. So now we are creating variants. We are creating, all the combinations of build types and product flavors. And again, locking happens so that after this configuration of those variants objects is done, no one is touching them, because they will be used in the end to create the actual tasks that will create all the build outputs and intermediate artifacts and so on. But this time with the new AGP versions and with the variant API, we are offering specially made extension points for you to be able to hook into any of these phases and influence what happens during that time. And what's super important, again, is that all of this happens during configuration phase. And only after the tasks are created, task execution happens after. So we're going to talk about the different ways you can defer things to happen later on. Okay, let's talk about how you actually register these extensions, these callbacks in your own code, and what you can do in each of them. So here on the left, we have a typical build Gradle file with some declarative configuration using the DSL that I mentioned before. And it's all using the Android block. So there's actually another one called Android Components, which lets you register all these callbacks that I showed you on the previous slide. And while you can do it, it's separate from the Android DSL. What's inside these blocks is not really meant to be declarative, or we're not calling it a DSL. It's separate from the Android block. And while you can register something like finalize DSL in here, we really don't recommend doing this in build files. What you should be doing instead is doing it in your own plugin. So this will make your code more maintainable. You will not mix declarative and imperative code in your build files. So basically what I recommend is always creating your own plugin, finding the extension in here. And here you have a real Kotlin file. You can write your code here. It's not declarative, it's imperative. Now, what you can do with finalize DSL, actually I had the example on the previous slide. What you get here is the extension object, which is exactly the thing you see on the left. So I showed you before that the block is just an application extension that you can find in the reference. This is what you get there. So it's basically you can do the same things. You can take whatever was configured in here and manipulate it in code. And previously, when I did this talk, people asked me, why would I do that? Why are you making it more complicated? And the answer is you don't have to. Like if all you want to do is configure your app, stick to the declarative syntax. If you want to somehow influence it, maybe generate your build types from code, maybe you have 50 of them. I had someone with that use case. And you don't want to have super long build files, maybe you can do that in a plugin. Maybe you can do it in code. Or you're just writing a plugin to reuse some kind of configuration across different builds. So you can use that as well. However, the only thing you can do in finalize DSL is basically the same thing you can do while configuring your app. Okay, so let's talk about the next one. The next one is more interesting. So the next one is before variants. And here you get an object that's called variant builder. And this callback happens right before the variants are actually decided and created. So by that time, the DSL is locked. We know what kind of build types we have, what kind of product flavors we have. You also can still read some stuff like min SDK and other properties that were set in the DSL. However, the more interesting thing you can do here is you can actually enable or rather disable certain variants before they are created. Maybe to make your build faster, maybe because you don't care about them. Maybe you're not using tests in some combinations of your build types and product flavors. Like maybe you're only testing debug and release, but not staging, whatever you want to do. So this is the last moment where you can influence which variants will get created or not created from your build. And actually, there's one more thing I'm showing here on this slide. The before variants and also the next one, the on variants callback, accept a selector that lets you narrow down the type of variants according to name or flavor or build type that you want to get the callback on. So this is something you can use. And then you can enable or disable the whole variant, or you can just disable Android tests or just the test. But again, all of this happens at configuration phase. So still, we did not have a way to defer anything to execution. So how do we do that? That's because everything that happens in these steps needs to be finalized before going to the next step. So last chance on variants. So what can we do on variants? So again, we can register our callback. We can use a selector. So maybe we just care about doing something with the release build type. And then you get the variant object. So the variant is now created. This object will be used to configure the actual tasks that compile and package your app. And the first thing you notice is that for the first time, every property on the variant object is no longer a concrete value. It's an actual Gradle property. So all of the stuff that you can set on the variant object, you can either set actual values or you can set other providers. So you can make it lazy. So here I'm just setting a value, a string. The other thing it gives you access to outputs that will be produced by the build. And so here, for example, I am taking a single APK output that will be produced. And what I want to do is I want to compute my version code. So this is the example that I showed you before that wasn't possible with just the DSL. I want to compute it using some task. And so what I can do is I can register my task. We now know that we get a task provider from it. So this task executes potentially when it's needed, it will be called. And then I can flat map its output of that task and set it as the version code. So I set it on the version code property of that output. Now, whenever I start building my app and AGP creates all these tasks and decides, I need to run task, whatever, packager to package the APK, it will notice, oh, my input is actually set to the output of the version code task, and it will transparently, silently call your version code generating task during the execution phase to let you generate the code however you want from the network, from Git. You can do whatever you want because it's now in the execution phase, and it's wired properly to the property of the variant object. And now a variant actually has one more thing, which is called the artifacts API. So you can access the artifacts object on it. And that's the last part of the presentation. So let's talk about why we have this and what it gives you. So to start talking about it, let's go back to this is a fake graph, by the way. This is more or less what can happen in a typical AGP build, but it's way simplified. So don't feel like I'm telling you how AGP works here. But imagine that AGP has to do some of these things, like it has some compilation tasks that take your sources and turn them into classes. Then it has the dexing tasks, as we discussed, that create the dex files, which it then packages to APKs or AABs. And then similarly, it has some kind of merger that takes all the manifests and puts them into one manifest that gets packaged, same with assets. But what if you think about this thing in terms of the actual artifacts that exist instead of the build tasks, which, as I said, they're a brittle API. We don't want to depend on tasks because they change. We can combine them, we can split them, we can add new ones. But these artifacts have to exist at some point during the build, right? There will always be classes, there will always be a manifest. So what if instead we had an API centered around these artifacts? So imagine you have your merge manifest, the final manifest that gets packaged into your app. What if you could get the final version of it and maybe inspect it in your task? Maybe you want to have a task that checks if there are any permissions that you want in there, don't want in there. What if you could transform that manifest, get its contents, look at it, maybe change some values and put it back into the compilation pipeline without actually knowing the tasks that are involved? Or maybe you just don't want to use the manifest merger that we have, and you just want to create your own manifest that will be used instead, without actually, while discarding the one that was created through our own merging. So you can do all of that. And here is a list of artifacts that actually exist in the API as of version 7.1. We keep adding them once they stabilize. So you can look at stuff like the class directories, the class jar files that come from libraries. You can inspect assets. You can also get the final outputs of the build, so the AAR, APKs, bundles. You can look at the merge manifest and so on. So this is taken from our reference documentation. You can find it on the artifact class. And then even here, you might notice that some of them are called multiple artifacts, some of them are called single artifact. What does it mean? So let me give you an example of two very different artifacts that we have and explain all of the possible properties that they might have. So first of all, multiple artifacts represent artifacts that represent multiple file system locations. So they can represent multiple directories or multiple files. That's when they are multiple. Single artifact, always once. So there's only one merged manifest. There might have been more manifests before, but the merged one exists as an only single one. Now, here in the type parameter, you can see if an artifact represents directories or files. So, you know, of course, classes directories will be a set of directories. The merge manifest is just a regular file. And then they implement interfaces that tell you what you can do with those. So, for example, for the classes, you can append new ones. So you can create and add your own classes to the compilation. You can also transform them. So you can take the classes that we have, do some processing, and transform them to something else. On the manifest, similarly, we can transform it. We can also replace it with our own. So that is when you create your own manifest and inject it into the build. So let's look at how this works. Again, you access it from the onVariants callback, where you get the variant object. And with every, by the way, every artifact supports getting the final version. So this is the simplest thing we can do. So here, we get the artifact that we're interested in. So that's the merge manifest. And what you get is, again, a provider. Like I said, providers are central to everything that's happening here. So you get a provider of the merge manifest, and you can wire it up to your own task as an input. Now, whenever you run your own task, that will tell Gradle to actually produce that merge manifest. And you don't care what tasks are needed to create that manifest. AGP will take care of everything and will give you the merge manifest when it's needed at execution time. So that's the easy part. For all of the other operations that actually transform or create or append to artifacts, the API is slightly different. So first of all, you need to create or rather register your task that you will use for your transformations. In this case, I'm registering some manifest producer that will just create a new manifest that I want to use in the build. And then you use this kind of Fluent-like API where you first say, I will use my task, so I will use my manifest producer, and then you wire up the inputs and outputs. In this case, there's only one. There's only the output of my manifest producer. There are also other types of this wired method that accept different parameters for directories or files, inputs and outputs, and so on. You need to choose the right one for the artifact that you're using. And finally, I will use it, you specify the action. So I will use my task wired with these outputs to create the new manifest. Instead of to create, you will also find methods like to append, to transform many, and so on. So you choose the right one depending on what you need. So this is it for today. We actually have a new page which has most of the information that I covered today. It's called Extending the AGP. You will find everything about providers, properties, variant API, and the artifacts API. We also have samples on GitHub. So this is a repository where we have these small recipes that represent basically small sections of everything that I told you about. You will find recipes that let you influence stuff using the variants API. You have recipes for replacing artifacts, creating artifacts, and so on. In 3 versions, actually. So we have them in KTS, in Groovy, and in actual plugins in the build SRC directory. And also the reference that I talked about, so where you can find the actual application extension and other classes related to all of this, we have that on DAC as well. Things we did not cover. When I said configuration needs to run every time during whenever you invoke a build, I lied a bit. There is a new feature in Gradle coming up. It's currently incubating. Is called configuration caching. And for specific scenarios, and all plugins need to be made compatible for this to work, configuration can be cached and saved to disk so that the next time you run your build, instead of running the whole configuration phase again, recalculating the task graphs and everything, this can be read in from the disk, from the cache. But again, all plugins have to be compatible. If there's one thing that kind of breaks this cache, then it will not work, and everything has to run again. There's also an extension mechanism where you can kind of add your own extensions or configuration blocks to our own variant objects. I didn't cover this before during this talk, but we have examples and recipes, so you can find, I believe it's called DSL extension. And then there's in the variant object, there's also a new ASM API for class file transformations, but this is a topic for a whole different talk and probably too advanced for most needs. So this is it. Thank you, and I think we have some time for questions. Cool. Any questions? Yep, please.
Thank you very much for the presentation. Can we get a graph of all the tasks created by AGP with all the dependencies between all the tasks? Like the one you showed, but more?
You shouldn't. You shouldn't need to know what the tasks are because they will change from version to version, and they are changing. So you can do it using various Gradle APIs. But again, we're not offering our tasks as a stable API. We don't want you to find out the names and everything because you shouldn't be depending on it. You should be depending on the artifacts instead. If you have a use case, we can talk about it later, but it's not recommended because from version to version, your own plugin will break if you try to introspect into our tasks and figure out what they are. Okay, go ahead.
What happens if two plugins or maybe one plugin tries to fight for both being a replacement for the manifest merger?
Right, so in general, multiple plugins can register all of these transformations. In the case of replacement, that's a good question. I think probably the last one will win, or it depends on the order of how you apply the plugins. I'm not exactly sure, but for sure, multiple transformations and multiple plugins can register those transformations, and AGP will make sure they all run. But like you said, with replacement, it might be a tricky case where one of them just overwrites the other because that's what replacement is. So maybe they should be using transform in that sense. Okay, cool. I'll be here for a few minutes if anyone has any more questions. Thank you.